Okay, now I will discuss about Pushdown Automata. So here the aim of the session is to provide understanding of Pushdown Automata and its structure, working principle. So instructional objectives. So here instructional objectives are designed to introduce the concept of Pushdown Automata and its components, including a stack, the behavior and the transition rules of Pushdown Automata, and the recognition of a language. So here there are learning outcomes. So here at the end of this session you should able to define what is Pushdown Automata and components like states, input alphabet, stack alphabets, transition function, accepting the states, acceptance of context free languages, understanding the relationship between Pushdown Automata and context free grammars in the context of language recognition. So now we will see some components. First of all, context free languages. So here context free grammar will generate context free languages that is accepted by the Pushdown Automata. So here Pushdown Automata, it is similar to finite automata, but it is having a component called stack for storing and processing information. So these are the components of Pushdown Automata: input string, states and transitions, and stack also. So here it is having the input tape, so it will store the input string. So in stack we will store the stack alphabets. So here stack will have stack symbol at the beginning. There will be Z0, it indicates bottom of the stack. So stack symbols, so they are called as stack symbols. So now, so here Pushdown Automata, what it will do is it will consider the current state and the current input symbol on the top of the stack. Then so it will replace top of the stack with new symbols, new stack alphabets. See here, so it will insert, it will push the symbols into stack by considering top of the stack and current input symbol. Next, so here it is having two operations, pop and push operation. In push operation it will insert stack symbols to stack. So in pop operation it will remove the top of the stack by considering current input symbol and top of the stack. So and one more action is there, no change. So here for some inputs, so it will consider the input, current state and top of the stack. The stack remains unchanged. So this is called no change operation. So these are possible transitions. See here. So input. So in input tape we are storing input string, and in stack there will be stack symbols. So it will consider the current input symbol and top of the stack. Then it will pop stack. It will process again. It will insert some data stack symbols into stack. Now, so it is a bad transition. Here input string will be there, so it will consider current input symbol. If the stack is empty, then the transition, that is called a bad transition. So it will halt. The Pushdown Automata will reject the input string. So here no transition is allowed to be followed when the stack is empty. If the stack is empty, then no transition is allowed. So this is about a good transition. So here it will consider the current input symbol on the top of the stack, then it will pop the stack. Next one, non-deterministic transition. So here Pushdown Automata, it will allow non-deterministic transitions. So it is called as non-deterministic Pushdown Automata. So it means it will consider the current state and current input symbol. So based on that it can move to one or more states. So that is called non-determinism, or we can call it as a non-deterministic transitions or non-deterministic Pushdown Automata. So now we will see for example, see here. So here we have For example, so here I am taking some string on the input tape, and I will process that. So at a time 0, for example, so here we have input A, 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 B, B, B. So now this will consider the current input symbol, that is A, and the top of the stack also. So at the beginning, top of the stack is Z0. So here assume that it indicates bottom of the stack. Okay. So now push down automata at a time 0. So it will be in the initial state, right? So now, so it will consider the input. So A. Okay, it means 3 A's followed by 3 B's, and at the beginning stack will have stack alphabet Z0. Okay. So now at a time 1, now see here, it will read the input. Okay, so it will read input A, so it will consider A, and so top of the stack is Z0. Okay, so here the language is actually A power n and B power n. So here n greater than or equal to 1. Okay, so it means it may accept strings like A, B, 2 A's followed by 2 B's, 3 A's followed by 3 B's, like that. Okay, so this is about the language, right? So now I will design a push down automata for A power n and B power n, where n is greater than or equal to 1. Okay, so now, so how to design push down automata, right? Okay, so here we are taking a stack. In the stack, at the beginning it is empty, so we are taking Z0, it indicates bottom of the stack, right? Okay, so now the push down automata, it will read, it will consider current input symbol and Z0. Okay, so here, so if you read A, insert X into stack. If you read B, pop X, right? For example, see here. Okay, Z0, right? So read A, so insert X. Again read A, insert X. Again read A, insert X. Okay, if you read A, insert X into stack. Okay, if you read B, then pop X, read B, pop X, read B, pop X. Then there is no input, right? We reached okay, end of the string. So now, so what about this? So it indicates bottom of the stack, right? So here there is no input. Okay, and stack it is having only Z0. It means what? The input is accepted. Okay, so now based on this, now I am going to design a push down automata, right? So here, so I am taking two states, so one for push and one for pop. Okay, so here at the start state or initial state, so this is initial state. So here no input. Okay, no input. So current input symbol is so I am not reading any input. Okay, for that I am taking epsilon. Okay, what about the stack symbol Z0? Okay, then no change on top of the stack. Then move to push state. So now again, now process the input, right? So read A. If I read A, okay, what is the top of the stack? Now Z0. Then push X into stack. Okay, push X on Z0. Now again read second A. Okay, that is the current input symbol now. Okay, top of the stack is X. So A X. Okay, A X. So what is A X? So insert or push X onto stack, right? So here top of the stack X. Now again insert X. Okay, again read third A. Okay, so now current input symbol A, top of the stack X. Then again push X into stack. Okay, so now we processed 3 A's, right? So that we got 3 X's in the stack. Now again read B. If it reads B, okay, so now I am in state push state, right? If we read B and top of the stack is X, then pop X. So pop X, so that I am writing epsilon. It means so in place of X you write epsilon. Okay, so here this will be popped. X will be popped from the stack. Again go to the pop state. Now what is the input now? B, second B, right? B, top of the stack X. Again pop action. Okay, so pop X. So now again there is one more input symbol B. So what is B? Again top of the stack X. So what is Bx again? Pop. Okay. So now we reach the end of the string, right? So end of the string means there is nothing is there is no input. So consider epsilon. So epsilon, it means no input. Top of the stack Z0. Okay. So no change in top of the stack. Then go to final state. Okay. So like that we can design a pushdown automata. Okay. So now I discussed about two things. Okay. So first thing, how to design pushdown automata. So how to design a pushdown automata. Second one, context-free language recognition. So here the language is a power n and okay, a power n, b power n. It means n a's followed by n b's. Okay. So that is the language, like a, b. Okay, 2 a's followed by 2 b's, 3 a's followed by 3 b's. Okay, like that. So this is the language, right? So how to design pushdown automata? So first we have to write all possible strings. Then we have to take stack. Okay. So at the beginning stack will have Z0, that indicates bottom of the stack, right? So now, so here we are taking okay, 3 states. So one is initial state. Okay. Then push state, pop state. Okay, and final state. Okay. So now you can design what are the transitions for push and pop states based upon the input. Okay. Okay. Now see here. So here we are not taking any language. Okay. So at a time 1, see here. So here whatever the language it is, right? So it may have some set of strings, right? So here we have to place the input. So in the input tape we are placing input. So at the beginning, so what it will do, the initial state, it will consider the current input symbol, okay, and the transition. So based on that it will move to next state. Okay. So now, so at a time t1, at a time 1, okay, so it will consider the present state and current input symbol and top of the stack. Okay. So based on that again it will perform some action. Okay, the action can be push or pop or no change. Okay, then it will move to next state. Okay, now see here we reached second state. Okay, now see here. So here, so it will consider the input symbol again. Okay, so this will consider. Okay, so this will consider current input symbol. Okay, present state. Now we are in second state and the transition. Okay, so generally the transition will be in the form of input, for example a, top of the stack, and it will do some action. So like push or okay, pop or no change. Okay, now so at a time 2 it is considering the input symbol on the top of the stack. Now here some symbol, it is a stack symbol, it is inserted into stack. Okay, next at a time 3, see here it will consider the second input symbol. Okay, so again state also, now it is inserting stack symbol. Okay, so now it will consider the third input symbol. So this is third input symbol. Okay, then state and transition, so it is inserting some stack symbol into stack. Okay, so here we processed 1, 2, 3 input symbols, so that we got 3 stack symbols. Okay, now so again at a time 5, now see here it will consider current input, okay, transition, then so based on this again, so what it is doing, so it can do a push, pop or no change. So now if it reads this symbol, now see here it is pop. Okay, it will remove element from stack. Okay, it is performing pop operation. Now again see here, read next symbol. Okay, next input symbol, consider the state, then do pop action. Now it is popped from the stack. So again see here, read next input, okay, consider the state. Actually this is pop state, okay, it is a push state. So now it will pop top of the stack. Okay, now see here, at a time 8, okay, we reached end of the input. So here there is no input, right? So if there is no input, and what about this top of the stack Z0? Okay, then you can move to final state, or you can call it as a acceptance state. Okay, so like that we can design pushdown automata. So here it needs three things. So input, tape, stack, and states. Okay, so here the states, it may have push state or pop state also. Okay, so here it is having three types of actions. So one is push, next pop, and no change. So actually it depends upon the language. So based on the language we can design pushdown automata. So here a string is accepted if there is a computation. Okay, so here all the input is consumed and the last state is the final state. Suppose in our previous example also, see here we processed the entire input, and in stack also we have only Z0. It means stack is empty. Okay, so that we reached final state. So it is about acceptance of a string or acceptance of a language. So now we will see non-deterministic pushdown automata. Okay. See here. So here also same thing only. So in non-deterministic pushdown automata, so it will consider the current input on the top of the stack. So based on that it can move to one or more states. Okay. So now I will take one more example. Okay, now I will take one more language. So I will design a pushdown automata per, so another language. Okay, see here. So design a non-deterministic pushdown automata to accept the language a power n, b power 2n. Okay, see here. So a power n. Okay, a power n and okay, a power n and b power 2n. It means see here. It means n A's followed by 2n B's. For example, if I have A, so then there will be 2 B's. Okay, suppose if I have 2 A's, okay, 2 A's, then there will be 4 B's. Okay, so this is about the language, right? So first we have to take all possible strings. Okay, then we have to design pushdown automata using stack. Okay, so now I am taking this string. See here. Okay, so I taken 2 A's followed by 4 B's, 2 A's followed by 4 B's. Okay, so now how to design pushdown automata, right? See here. First we have to take a stack. Okay, so you can take Z0 or dollar also. Okay, no matter. It indicates bottom of the stack, right? So now if I read A, okay, then push 2 zeros onto the stack. Okay, see here. So read A, then insert 2 zeros. If I read A, push 0 0 onto the stack. Again read A, 0 0 onto the stack. Okay. If I read B, then pop 0. Read B, pop 0. Read B, pop 0. Read B, pop 0. So finally the input it is processed. Okay, so what about the stack? So it is also empty, so the input will be accepted. So like that we have to design push down automata. Okay, so now see here. Okay, so now see here. So read A, so insert 0 0. So we have to take the states, okay, q1, q2, q3, q4. So here q2, q1, q2 for push action, q3, okay, again you can push. Okay, see here I am taking first a, it means 2 A's followed by 4 B's. Okay, if I read A, I have to push 0 0 into the stack. Okay, so 0 0. If you read A, then insert 0 0 into the stack. Again read A, 0 0 into the stack. Okay, if you read B, pop 0, read B, pop 0, read B, pop 0, read B, pop 0. Okay, so like that we can design push down automata. Okay.